Now, in the last class, we have seen what is worst case. In this class, we are going to talk about best case. Now, to understand best case, it is quite easy to understand. Let us say, today, the world record of fastest century is Rohit Sharma. Let's say in T20, we have got combined record from Rohit and Miller. Let's say 31 ball. So, this is our best record so far. This record can be broken. This record can be broken if somebody is going to hit a century of ball less than 31. Less than 31. If tomorrow AB de Villiers is going to score 130 balls in T20, that is going to be the best. After one day, if somebody is going to hit a century of 29 deliveries, this is going to be the best. Now, this same concept is there while implementing the best case time complexity. I have an algorithm where I have showcased that time complexity, this algorithm is going to take under best case, let's say omega n. Omega n. Or n. Forget about n. Omega. So, under best case, my algorithm is going to take how much time? N time. Let's say you are a developer, you are a very good developer, you did some modification and you implemented this program in less than this time. That means your algorithm was telling you that this work under best case is going to take n time. Let's say I can implement this in n by 2 times. So this was best. Anything less than that is always going to be best. Are you getting my point? Just like in similar case, if this is worst, under worst situation, this value can go higher. Anything more than that is always going to be treated as what? Worst. Same thing is there. If in ideal situation, my complexity is f of n, under best case, this is called lower bound. If anything we can achieve less than that amount, that is also known as what? Best case. That means, if two complexities are given, fn and g of n, Fn is the ideal complexity, Gn is after implementation, let us say we are getting some complexity. If I can write Fn is equals to omega g of n, what does it mean? Omega is representing best case. That means if this is the ideal situation, under ideal situation, Fn is always going to be higher than g of n or equal to g of n. That means this omega relationship can be written as what? Greater than equal to. Greater than equal to. While big O is represented by what? Less than equal to. That means what we need to prove? If we can prove this, Fn can be written as greater than equal to C into G of n. Same thing. C is a constant which is greater than 0 for any value of n which is greater than n naught which is greater than 0. If we can prove this, that means Fn can be written as omega of g of n. That's simple as that. So very similar to worst situation, we can write this also. Let me take two examples. Let's say f of n, g of n. F of n is n square, g of n is let's say 3n. F of n is n square, g of n is 3n. Now can I write f of n is equals to which relationship we can have? By looking at these two complexity, you can see this f of n is always going to be higher than this one because this is linear polynomial. So n is always going to be less than n square. That means this fn is always going to be greater than. That means which complex, what relation this can show? This shows best case. That means I can write Fn is equals to omega g of n. This cannot be written. Fn is equals to big O g of n. This cannot be written. Why? Because we can never prove for any value of n or constant, this Fn cannot be proved that is less than g of n. So only omega relation is possible. This is not possible. This point is clear? Similarly, n cube versus n square. Now this is always going to be higher than this one. So which relationship? Greater than equal to. That means I can write Fn is equals to omega of g of n. As simple. Now one more example. Let's say Fn is equals to n. Gn is equals to 4n plus 5. 4n plus 5. Let me take Fn is equals to let's say 2n. Now, can I write omega? See, at the current position, we can see this 2n is less than 4n plus 5. But what was the thing that we know? If we can prove that fn is greater than equal to c into g of n. C into g of n. So let me take a value. Fn is what? 2n greater than equal to, this is g of n, c into 4n plus 5. Under which situation 2n can be higher than this one? C is any value greater than 0. C value is any value greater than 0. If I'll take C is equals to 1 by 4 or 1 by 3, this will become what? 1 n plus something. If I take C is equals to what? 1 by 4, this will become 2n, can be written as greater than equal to n plus 5 by 4. Now you can see for a certain value of n, this 2n is going to be higher than this one. So I can write that fn is greater than c of g of n, and I can write, yes, fn can be written as what? C into omega. Fn can be written as fn is equals to omega g of n. This is true. This point is clear enough. Now point is very simple. Whenever two complexities are given, fn, gn. Now let me write a few complexity you are supposed to answer. 3n, 5n. One more thing is important. Whenever you are comparing same order complexity, this complexity can be written as this can be proved as well as this can be proved. Both are possible. That means I can write fn is equals to big O g of n. This can also be proved. Fn can be written as omega g of n. We have seen with one example. Both are possible. How come this is possible? If we have to prove this, that fn is less than g of n, what I am supposed to do? I have to prove in this way. Now, if I take C, you can say 3n is always going to be less than 5n. That is true. There is no point. We can prove it easily. But if we have to prove it is omega, then this is supposed to be higher than. Now, how do you prove 3n is higher than 5n? Simply take C is equals to what? 1 by 5. This will become n. This will become 3n. 3n is always going to be what? Higher than 5n. For C is equals to what? 1 by 5, and for any value of n greater than equal to 0. That's all proved. That means moral of the story is what? If two complexities are given, both complexities are of same order, you can write fn is equals to big O gn as well as fn is equals to this much. Now, forget about think about the last lecture. I told you whenever best case and worst case both are same. That means for this complexity we can write fn is equals to big O gn, fn is equals to omega gn. That means I can write fn is equals to theta g of n. I told you whenever best case and worst case both are same, in spite of representing with two complexities, I can represent what? Theta g of n. What is the meaning of this? Whenever we have complexity written in this form, if I say fn is equals to theta 2 to the power n, or like 2n, or like theta g of n, I don't know what is the value of fn and gn. That means this theta is going to indicate that yes, this can be written as big O g of n, as well as this can be written as omega g of n. That means when this condition is possible, if we are comparing two complexity of the same order, that means I can prove as big O as well as omega. So what is condition for this one? Fn is equals to theta gn. If we can prove Fn is equal to big O of gn, Fn is equals to omega of g of n. In books, how do you write same thing? This is true if we can write. What is big O? Big O is means less than equal to c into g of n. What is omega? Fn is always going to be higher than c into g of n. So let me take as c2 here, c1 here. That means if I can prove this, this will become what? Fn is equals to big O g of n. And if I can prove this, this is what? Fn is equals to omega of g of n. and if best case and worst case both are equal, then I can write one notation theta Fn is equals to theta Gn. So these are three notation: worst case, best case and average case. This point is clear. Now if any complexity is given to you, how do you calculate whether we have omega relationship or big O relationship or theta relationship? Let me write few complexities. Fn Gn. Quickly answer this. You can stop the video and think about this, and that's all, work is over. N square and n. What is true about these two? See, this can never be written, this n square can never be less than this one. That means this is always going to be higher than this one. That means which relationship? I can always have greater than equal to means what? Omega. This point is clear enough. Now let me take another. N cube n square. Under any situation, this is always going to be higher than this much. So greater than equal to means what? Omega. So I can write Fn is equals to what? Omega of g of n. Now if I write just opposite, n and n square. Under all situation, this is always going to be less than this. So I can write Fn is big O of g of n. Big O means what? Less than equal to. Let's say n cube and n to the power 5. Which relationship we have? Less than equal to. So which complexity I can write? Big O of g of n. Now the important point that you need to understand. Whenever you are comparing two complexities of same order. Same order means what? Let's say 3n plus 5, 2n plus 7. Both are of same order. So if somebody is saying whether this is correct, big O of g of n, yes, this is correct, because this can be, if we are comparing two complexity of same order, we can prove that this is less than this at any constant value and for any value of n. That can be proved, and we have seen it also. This is also possible. Same thing I told you, if you are comparing two similar order complexity, I can prove that Fn is equals to omega of g of n. This can also be proved. So this is also true, this is also true. If worst and best, though all are true, that means I can write what? Fn is equals to theta of g of n. This is also true. Point is clear? So this is how complexity can be compared. Now what is small o and small omega, we will see in the next lecture. Thank you very much.